Okay. Hello friends. So we shall study now voltage source inverter fed induction motor drives. This topic is very important for the exam point of view. So in exam you may get question like this with the circuit diagram and waveform explain the operation of voltage source inverter fed induction motor drives. Like this you may get the question. So let us study what is voltage source inverter. So why we call it as voltage source inverter? Because inverter acts like a voltage source to the induction motor. Inverter acts like a voltage source to the induction motor. That's why we call it as voltage source inverter, because whatever we are feeding to that motor, DC supply is given and it is induction motor getting supply through what? Through the inverter. It is giving the voltage to the induction motor. It is giving variable voltage to the induction motor. It is providing variable frequency to the induction motor. That's why main source for this controlled voltage is provided by inverter to the induction motor. That's why we are calling it as voltage source inverter fed induction motor drives. So why we need the variable voltage and variable frequency is that to control the speed of induction motor, we need the variable frequency and variable voltage. It is one of the speed control method. It is by controlling the frequency, by controlling the voltage, we can control the speed of induction motor drive, and we are keeping the V by F ratio constant here. So mainly we have switches. So switches nothing but we can say transistors. So transistors are controlled here. Time period of transistors are controlled to operate the inverter. And this figure gives the info, shows the voltage source inverter. And one more important thing is that this should have always a DC form. Input to the inverter is always in the DC form. So that is the important thing. Even though if you have AC, we are converting to DC and making variable DC supplies given to the inverter. That is the important thing. Let us study. So the main we have discussed that main component is the transistor or a switch. So it is transistor nothing but what? We have the MOSFET, IGBT and voltage GT, all these various transistors we have. So for different levels we are using the different transistors. That's why we have explained for a lower voltage MOSFET is used, and for a medium voltage IGBT, and higher ratings GTO or IGCT are used here. Now, so we have to control the transistor, right? To control the operation of transistor or whole system, we need to control the transistors. Then how to control the transistors? We are controlling the gate of transistors. How do you control the gate of transistor? There are two methods for that. One is the stepped wave inverter method or stepped wave method. Another is the PWM method. One is the stepped wave method. Another is the PWM method. In case of step wave method, what happens here? If you apply this method, the output of inverter is like this. This magnitude of voltage is constant. This is the time period of one switch. So one switch is operating for only 60 degree, because total 6 switches we have. 360-degree time period we have. 360 by 6 will give the 60 degree. So one switch operates only for 60 degree. So pi by 6, it is starting from 60 degree and next 60 degree it will end. This half cycle we are taking. So this is the magnitude of the voltage. It is the magnitude of voltage is present. In case of stepped wave, we are getting the output like this. So this waveform is the output of the inverter when we apply the stepped wave method. If you apply pulse width modulation inverter, if you apply PWM method, what we get here is that we are getting voltage like this. So we are getting the pulses. So one more advantage for this PWM method is that we are getting the variable values here. So pulses we are getting means what? Variable pulses we are getting means what? voltage also we are varying, we are getting the variable voltage and variable frequency with this method. Whereas in case of this step wave method, we don't get the variable voltage. We get only variable frequency will get. That is the disadvantage of step wave, and this is overcome by PWM. So we are getting the variable voltage. You can see that different voltage waveforms we are getting, right? So we can get the variable voltage and variable frequency. Both we are getting. Next, if supply is DC, then what happens here is that, so we are checking now, supply is DC. So what you have to do, if supply is AC, what you have to do for a step wave? So inverter is controlled by step. So if supply is DC, we have to convert that to variable DC with the help of chopper. Chopper nothing but DC to DC converter. We have to control from DC to variable DC, and it is coming from through the filter, which reduces the ripple that is given to the inverter. So the switch operates, then frequency, variable frequency we are getting in the inverter. By operating the time period of switches, we can get the variable frequency, and variable voltage we are getting through this chopper. So if supply is AC, rectifier is used. Rectifier is used to convert AC to DC, and controlled output will get that to filtered by this capacitor. So variable voltage we are getting, variable frequency we are getting through this inverter. By controlling the time period of transistors, we can control the frequency like that. So induction motor is fed from the different kinds of supply. So anyhow, we should get the DC supply at the input side of inverters. That is the important thing. Next, similarly, you can get the yes, same thing. So if it is a PWM inverter, same again. If DC and AC, we have to convert that and convert and given to the inverters. That is the important thing. That is the important thing. Only thing is that they have explained the for a different methods, different supplies they have given and explained with the diagrams. That is the important thing. Next we have. So next we have, as we have discussed that, what are the limitations we have discussed that. So limitations of stepped waveform. So it is not possible to obtain the variable voltage in case this kind of step wave inverter. So we cannot get the variable voltage. Only we get only variable frequency. And what happens here? Due to that, what happens here is that low frequency harmonics will enter into the pitch. So what happens here? If because of this low frequency harmonics, pulsating torque will be generated. Due to that pulsating torque, the jerks will happens in the motor operation. Whenever motor operates, it feels that there is a jerk in the operation. There is a vibration, more vibration in the operation. Then that increases the losses and overheats the machine. So these limitations are overcome by advantages of overcome by PWM. So those are called as advantage. So those limitations are overcome by this PWM technique. So due to that, what happens? So variable voltage will get, variable frequency you are getting, harmonics are reduced, losses reduced. So motor operates smoothly. So this is the explanation for voltage source inverter fed induction motor. If they ask this question, so draw the diagram, explain that, and controlling methods you explain, and limitations explain. If DC supply is given, what to do? If AC supply is given, what to do? Those things we have to explain properly. So this is the explanation for VSI fed induction motor drives. Thank you.